We're, just, haha, we're back. A little more math, ready to go just for you all. But of course, before we get started with math, what do we do first? A little bit of fun. At least I have fun with this. If you don't have fun with it, we'll skip forward 2 minutes. Totally fine. Start with the pins. I feel like the pins are pretty good to start off with today. A little good trio here. We've got some the Dumbo flying elephants. The mascot line of pins. Pretty good set here. Some Aladdin and Jasmine. Awesome. And y'all may not remember this, but there used to be a thing called Indiana Jones. It was awesome. Here's some little Indiana Jones Mickey ears right here, ready to go. Pretty good set for the day. Let's see. Oh, we got to open up some stuff, of course. Let's go over to the side over here. We got a couple things. A Pixar bag clip. It could be anything. Let's see what we got. Oh, fantastic. WALL-E, one of my favorites. Solid Disney Pixar movie. You can sit up here by Yoshi. Also got little DC figurine. Little Lego guy can go up here with Green Lantern. Who's it gonna be? Aquaman with a fish. Fantastic. Well, that makes sense. I mean, Aquaman would have a fish, right? You can sit up here with Max Scherzer and Green Lantern in front of a bowl. And finally, little Star Wars. Why not, right? Get out a lightsaber for this. It's not going to work very well. Oh, sweet. Got a Finn bobblehead. Sure, why not? Pretty good. I can hang out right about here too. Green Lantern, it wasn't a very good movie anyways. It's okay. So I'll set the side. Oh, it's time for some quotes. We got some great little throwback quote from last week. If Facebook has taught us anything, it's that a lot of people aren't quite ready for a spelling bee. So true. I mean, I'm a math teacher, I get it, but like seriously, some of y'all really need to work on the difference between your and your. Sometimes you need an apostrophe, sometimes you don't. It's okay. Today's quote. Warning, I'm bored. Things could get freaky. I think that might be the summation of these videos right here. It's possible. I'm not saying I'm getting looks from people in the room. Whatever, it's fine. All right, so we've opened up some stuff. We did some pins, some quotes of the day. You know what that means. It's time to do some math. Let's go to the board. Here we go. All right now, Billy Madison, Danny McGrath. Man, am I glad I called that guy. Pay attention. This will be on the quiz. Algebra guys, we're back. Round 2 of the elimination method. Yesterday we worked on solving our systems of equations when they had wonderful coefficients in both equations for one variable that were the same, or the opposite, which was really convenient because then we had to do a lot less work. But today, for part 2, we gotta get a little more complicated, right? Well, we're really looking at solving systems like this, where we've got 9x plus 2y equals 39, and 6x plus 13y equals negative 9. There's something up here. We said we wanted to have the same coefficient, right? We don't in any of these. What can we do to make that happen? Of course, you all remember this. We're going to multiply the equations by something, each equation by a number, so that we can end up with the same coefficient from one of the variables. In this case, I'm going to eliminate x. Because I notice 9 and 6, the least common multiple of those two numbers is 18. So if I were to multiply this first equation by 2, I'd have 18x plus 4y equals 78. Multiply this whole second equation by 3. I'm going to multiply by negative 3 so we can just do a little adding here. Negative 3, we end up with negative 18x minus 39y equals 27. Okay. So now we're going to add these equations together. By doing that, we get rid of one of our variables, which means I'm left with negative 35y equals 105. Single variable equation. We know what to do here, right? All we got to do is divide by our coefficients. And y equals -3. We're done, right? Of course not. Of course we're not done. We've only found y. We've got to find what x equals. How do we do that? Well, pick an equation. Either one of our first two. I'm going to go with the first equation here. I'm going to solve for x. So, 9x plus 2 times our value for y equals 39. 9x, 2 times -3 minus 6 equals 39. Add 6 to both sides of the equation. 9x equals 45. Divide by 9. X equals 5. So that's our solution for the system of equations. Right? Pretty simple stuff. Markers stay. Markers. All right. So, pretty easy process. We have another one right here we're going to look at. This time, instead of eliminating x first, we're going to try and get rid of y. Shows just, again, the same process, nothing changes. 7x plus 3y equals -12. 2x plus 5y equals 38. Let's try and get rid of the y variable. We'll do that. Means I've got to have the same coefficient here. So, I'm going to multiply this first equation by 5. The second equation by -3, which works out nicely. A little convenient to do that again. So we've got 35x plus 15y equals -60. -6x minus 15y equals -114. If I did that math right in my head, and I did, check my notes just to be sure, worked out pretty nicely. We're going to add the equations together. We get 29x equals -174. Divide by our coefficients. X equals, to the back of the classroom, back there, in the back, the one sleeping. Wake up! That's right. Okay, here we go. Not asleep, it's okay. Divide here, we get -6. Now we just got to solve for y by plugging in our value for x into one of the equations. And let's use the second one this time. 2 times -6 plus 5y equals 38, which means -12 plus 5y equals 38. Add 12 to both sides of my equation. 5y equals 50. Divide by 5. Y equals 10. Look at that. We've got our second solution to a system of equations. All done nice and easy. Isn't that great? Super simple. Well, again, short review here. So we got one more part. We're going to do a little word problem. Once again, I know you'll be all right with it. And then we'll be done for today. So, be right back. Just a second.
A lot of boring math later.
We're back for a real world problem here, okay? So we're looking at orders of dumplings. Fried dumplings, I love them. They're delicious. I'll put some soy sauce. Ooh, it's good. Oh, it's good. So you have a restaurant though. It sells orders of small orders of dumplings, large orders of dumplings, okay? If you order 3 small and 5 large, it would cost you $28.20. And for 4 small and 3 large orders, it would cost you $23.20. Question for you, what would be the cost of 3 small orders and 2 large orders? In order to do that, we just have to come up with a system of equations, like the one right here, where I'm going to use S for the small order cost, L for the large order cost. Now we're just going to work with a system of equations just like we've been doing all day. So, we've got to get rid of a variable. Since I don't have the same coefficient in front of anything, I'm going to go ahead and multiply out here to get rid of S. I want to get rid of the small orders. I'm going to use my notes here to help me out, make this quick on you. So, we multiply this out, we get 12S plus 20L equals 112.80. And negative 12s minus 9l equals negative 69, 90. Okay. Now if I add these equations together, that cancels out. That's 11l equals $42.90. 42.90, which means we just need to divide by our coefficient of 11. And we get a cost for the large order of $3.90. We're holding this piece of information. We're going to need to use that back in a second. Now that we know the cost of a large order, we can find the cost of a small order. So we're going to pick one of these two equations to start with. I'd say let's pick the easier one, the smaller values, right? 4s plus 3 times 390 equals 2330. Excuse me. So 4s equals, oh sorry, plus, not equals. It's 1170 equals 2330. Right? Make sure my math is right here. Looks good. Let me subtract. 1170 from both sides. 4 small orders of dumplings would cost $11.60. Divide by 4. S equals a small order is going to be, I get $2.90. So we know the cost of a small order. We know the cost of a large order, which means we put them together. Three small orders, not large, 3 small orders plus 2 large orders is what we're trying to find out. Just replace. A small order costs $2.90, so 3 times $2.90 plus 2 times $3.90. And multiply it out. Let's you work on that for a second. Should get how much? Using the card for this. Should have a $16.50. Easy enough, guys, right? Using our systems and equations, able to solve some actual real-world problem that you might use in the real world. How about that? That's about all for the day. We'll be right back to close this out and get you ready for tomorrow's video. Of course, where would we be? Every day we do it. Shout out to the siblings, Anthony, Ross, Becca, Nelson hiding behind the softball over there. Thank y'all for coming to do some math with me and my students. It's such a joy having y'all experience the math all together. It's really just a blast. I think we should do this again tomorrow. So again, weekend review. Going to continue on tomorrow and Friday. We're looking at forms of linear equations. Something to help you remember about standard form, slope-intercept form, point-slope form. Right? Remember all this stuff from school? Awesome. Until then, son of the teacher of the universe, the Algebra 1 champ, the middle school math champ. I'm just saying, the champ is here. We'll see y'all tomorrow. Have a good one.